Hi everyone, today we're going to be looking over the 2016 AMC 8, specifically problem 23. This is a harder problem for me, but I found a method to solve it that's not like these methods. See, these look really complicated. Like, look, both of the radii of the same circle, all that. That's too complex. I'm going to explain it in an easier way so that you can understand an alternative solution for the problem. So, two congruent circles centered at points A and B each pass through the other circle's center. The line containing both A and B is extended to intersect the circles at points C and D. The circles intersect at 2 points, one of which is E. What is the degree measure of CED? One thing you also notice in this, they didn't draw it out. I think it's important to draw it out so that you can visualize. So, our choices are 90, 105, 120, 135, and 150. So, we're going to draw it out. I'm going to draw two circles because it says they're centered at points A and B. Since they pass through the other center, we can go ahead and draw one here. And draw one here. Make sure they're equal. Okay. And we're going to start labeling. We can see that they're both centered at points A and B. So this is the center, the first one. And we know because it looks like the center, first of all. And second of all, the circle is passing through. So we can go ahead, I'm going to label it in red actually. This can be A, right? And this can be B. Now it says the line containing A and B is extended to intersect at C and D. So we can create a line out of this. I'm going to use black. But it says it's extended. So that means it can go on until here. It can go on until here. Right? So it says that it's intersecting at C and D. So we can go ahead and label that. This is C. This is D. Last thing to label, it says the circles intersect at 2 points, one of which is E. So let's look where they intersect. This is a point of intersection because both circles are touching each other at this point. So this can be E. And it says one of which is E. But really, it doesn't matter which one we choose. So I'm just going to label this one as E as well. Okay, let's get on with the problem. It's asking us to find the degree measure of CED. What does that mean? That means this. You know what? I'm going to actually use straight line just so it's a little better. C E D. Okay. This is actually a triangle, as you can tell. But since this is also CED, we can label it. By the way, there's so many different ways to solve this problem. This is just how I would solve it, okay? So, we need to find the value of this angle. Oh, sorry. I'm going to go back here. The value of this angle. Now, one way that we can do this is by making an equilateral triangle. So, this is where my strategy differs from other strategies. Sorry, that was a bad line. Okay, so this is an equilateral triangle. How do we know that? It's because all the angles are 60, first off, and second off, all of these sides are equivalent. Now, that also means that this is also an equilateral triangle. So that is actually helpful because all the angles in a triangle add up to 180 degrees. Now, since there's 3 angles in a triangle, and this is an equilateral triangle where all the angles are equal, we can actually just divide it by 3. This gives us 60 for each angle, right? So this is 60, this is 60, and this is 60. And that's helpful because now we just need to know the value of this angle. You see, because we have part of this angle, but we also need to find this angle and this angle, which are from these triangles, right? So this is where you can see that a line is actually 180 degrees total, right? And since we know this is 60, we can do some simple subtraction. 180 minus 60, and you get 120. Therefore, we know that this angle is 120, so is this angle, right? Because these are equivalent triangles. This and this are both equal. So, again, we know all angles in a triangle add up to 180. So what we can do is 180 minus 120 to get 60. This tells us what the sum of this angle and this angle is. So we know these two add up to 60, but we don't know what they are yet. But there's a way that we can now. See, circles can actually be turned into a bunch of equilateral triangles. So this specifically, it might be a lot to see right now. It might be pretty complex, but just stay with me. Okay, so we can actually make more. I'm going to use the green again. We can make more equilateral triangles. Okay. And we're not going to use all these in the problem. We're just going to, so you can see how they're all made up. All the green, it makes up this circle. And if we wanted to, we can make up this circle as well. But we're going to stick with this one. So what you see is all of these angles are 60. You know that for sure, right? But what we need to figure out is the angle of this triangle. I think it's kind of hard to see that now because of all the lines, so I'm going to outline it once more. I'm going to use U. Right? Again, we know this is 120, but there's something now that we know that we didn't know before. This side of the triangle and this side of the triangle are actually equal. We know that because all of these triangles, all of the sides are equal, right? And since this is actually just the side length of this triangle, right? And so is this. So these are equal. Now when we have two equal sides, it's an isosceles triangle, but it also means we have two equal angles. So, now that we know that, since this is 120, we can do, we know that these add up to 60 and they're equal. So we can just do 60 divided by 2 to get 30, right? So now we know that this angle is 30, and also we know that these two triangles are equivalent, right? So this is also 30. So that means that this whole area is just the sum of these three angles. So you can do 30 plus 30 plus 60. That actually comes out to 120. Okay, that is our answer. Angle CED is equal to 120. So it's letter C. Thank you guys for watching this video. I hope it helped you if you were stuck on this problem and you want an alternative answer. Bye everyone.